assurance these things?
What, the llamas?
Yeah.
How do you quality assurance the existing CISOs?
Well, I think that's a problem.
There we go. I mean, no better or worse.
Check.
So no better or worse. Squirrels in your computer. Gerbils in your computers. All right. Without any. So do we have any more ados? We have a thumbs up. All right. Without any further ado, I would like to introduce Andrew and Rock, who will be talking about big data at scale. Or attacking big data at scale. So please give a warm ShmooCon welcome.
Hey, everyone. I'd like to thank you all for taking the time to come here, look at our presentation. Before we get started, we have some sponsor donations. We have some cherries up here. If any of you play buzzword bingo, are you in the right place? At the 10th mention of big data or machine learning, we will give away both jars of cherries.
You have to keep track, though.
So, yes, we encourage user...
Yes.
All right, so getting into the presentation, the motivation behind why we did our research over the past semester, big data and machine learning are everywhere. There are government entities such as the Environmental Protection Agency that now have a manifesto online. It's like this is how they will drive daily operations through the output of data analytics. Politicians are looking at public sentiment online as to how well they're received in recent polls. We have this beautiful picture here of Deadpool on a bearskin rug because of people on Twitter and movie actors such as Ryan Reynolds talking like, hey, this is the thing the fans want. And Hollywood, understanding that there's a desire and a demand for this product gave way, because the analytics showed that they could make a profit from making such a movie. So, with this said, what if we're in a paradigm shift where adversaries no longer target users, they no longer target systems, but they're now targeting the decisions that their victims are making? What if an adversary can control the output of data analytics and machine learning so that they can control their victim? And that's really what our research gets at for today.
So to unpack this a little bit, what is machine learning and what is big data? Well, so with machine learning, you say, well, I have this ocean of data or facts or observations about the world, and what I want to do is I want to extract some meaning from that. I want to be able to say, how many people on Twitter are really interested in or express positive sentiment about Deadpool. Of all of the photos that are taken around the world, how many of those photos contain some image or pattern that I'm interested in? If I have all of this information about car accidents or all this information about vehicles and their daily drive, how do I take that information and process it and produce some kind of decision or insight into the world around us using that information? So this has really taken off as we've gotten both the ability to acquire this information and the ability to process this information in a way that sort of is a little unparalleled in the history of civilization, because previously you would be constrained by how much you could collect, how much you could store, and how much you could process. For example, one thing that I've been studying recently is the history of integration of technology into the US Navy, and there's this excellent book titled When Computers Went to Sea, and it explains that sort of in the early days of using radar, most of the data analytics that was done by a group of sweaty men in the Combat Operations Center. That was what it was originally called, by the way. It was very quickly renamed to something else. Think about what that acronym is for a little bit. Once we get more data that can be dealt with by people using grease pencils on a chart, like what does this do and where does this go? So machine learning sort of is that next frontier. How do we deal with and process this information? So to quote the prophet Swift on security, big data is data that doesn't fit in Excel. Now, if you've really worked with Excel, you'll know that there's quite a bit of data that actually can fit in Excel. Excel has this, I've been told, I don't do professional Excel, but people I know that have done professional Excel tell me that it has this back end that can go to HPC, which is kind of nuts. But anyway, if you get, multiple petabytes of information and you want to extract some information about it, you're not going to do that by hand. You want the machines to do that. That's sort of the overall history of where all this stuff goes.
So getting into our research, here's our 3 essentials moving forward. Obviously, us being poor, we wanted something open source and something that is transparent as we get into it. We want something that's going to have an immense impact. And also we want something that people are familiar with. It's pointless to do research on something that no one cares about or something that no one's ever heard of. So with these three things taken into consideration, we move into an actual failure that we had. Our talk is about a survey of new attacks against big data and machine learning. Turns out there's quite a bit of research in academia about adversarial machine learning and dorking with data analytics to skew the output. So to rehash some of the previous work done, there's people looking at insufficient data types. So earlier Andrew mentioned, we're concerned about, the average number of miles people drive per year and the correlation they have with, how many accidents they have per year. Insurance companies care about these sorts of things. But as they're ingesting, public feeds of this information, does it make sense to have a negative value? Does anyone ever drive negative miles a year? And Ferris Bueller's Day Off does not count, did not work. And so this is an example of a lazy developer not doing sanity checks on the input that they're ingesting. And then there's also looking at normalization. So let's say Star Wars Force Awakens just came out. There's lots of public positive sentiment about it. The best movie ever, or it's pretty good. But if you're not normalizing that input as between 0 and 1 as how favorable someone's looking at it, Twitter is confined to 160 characters. So what if someone wants to screw with someone doing data processing on Twitter feeds and build a spam tweet of bad, horrible, other negative superlatives of how they felt about that. They're now able to offset the positive sentiment of 20 plus people by crafting this malicious tweet with intent of dorking with analytics. So as I mentioned earlier, a lot of this has been done, and we found that we were failures and that we couldn't find anything new with influencing the output of data analytics. But what we did find was a exploit that works against Hadoop that harkens back to the late 90s. And they called and want their hack back. So data exfil is possible with Hadoop clusters we found using URL encoding abuse and directory traversal. You're like, this is, what year is this? And this is still possible within the relation between a HDFS, a Hadoop distributed file system client, and the remote cluster that they're uploading all this data to. So you have this, URL encoded string on the pooter, and when that's decoded, it actually allows directory traversals, either absolute or relative file paths. And because there's no standardization or tokenization on the command that's given at the command line, it decodes this URL and starts to look for, does this file exist? It doesn't treat it as information, it treats it as part of the command. And because this is possible, you can have exfil of sensitive data or restricted data by an insider threat. And we reported this, we tried to do responsible disclosure, and there was little interest because of the narrow attack surface that this is possible through. But I can't think of any reason why someone would be concerned with insider threats this day and age. So here's one. It's not really part of our talk, but it's a freebie.
By definition, it's part of our talk now.
Yeah, you're welcome. So, all right.
So another example that so part of what I do is I sit around and I think of scary things and how bad the world would be if they existed. So here's one thought experiment I had. Let's say that you sit down and you're concerned about finding. Let's say you want to make the world you want to make a real life where is Carmen Sandiego infrastructure on the internet. So you say, well, okay, this actually, like nowadays, this is kind of interesting. What we can do is I'll set up a bunch of EC2 instances in an S3 bucket. And what these instances will do is they'll go out and they'll gather images of the real world that were taken with some indication of where and when those images were taken and just dump them into S3. And then I'm going to run computer vision algorithms on all of those images in real time and try to figure out what I can figure out who was where, when. I'm going to dump that information into another S3 bucket. And this can just sit in the background of the internet running forever. And as it produces information, it can give it to me. So that sounds interesting, and you think, wow, all of the pieces are sort of sitting around, and I could use them. But it turns out that because we write all of these algorithms and all of the system software on top of C and C++, it's sort of built on this pile of quicksand. So as soon as someone figures out that this is a thing that you're doing, they start to attack you. Maybe they don't like you. Maybe Carmen Sandiego is a computer hacker, and she doesn't want to be found. So she figures out, oh, there's this system that's pulling all these images. I can add images into that system too, and I can get at this particular infrastructure and start to corrupt its decision-making process one way or the other. I can either tell the system that I'm somewhere where I'm not, or vice versa, via a trick played at a high level on the image recognition algorithms. Or, let's say the image recognition library contains a low-level vulnerability in the way it parses PNGs. I could get a shell on this EC2 cluster and then fill the system with sweet, sweet lies of any nature that I want, or shut it down altogether. So another excellent concept that's enabled by this future is the concept first posed by Neil Stephenson in the book Zero History, which is the idea of the ugly t-shirt. So the ugly t-shirt was posited in this book as a compromise between entities that created a sort of surveillance system based on video data, where anyone who wore the ugly t-shirt was sort of erased from existence as far as the surveillance system was concerned. But in a world where all of the watchers in this system are built on top of systems written in C and C++, if you're lucky, you identify the components of an ugly t-shirt just by studying some code. And that's a little weird, right? So what we did was we looked at this platform, this computer vision platform called OpenCV, which is an open source system. You can just download the code on GitHub. And we were like, okay, so this is pretty rich and this is pretty mature, and also there are all these examples where we can just start from, here's an input image or here's a movie image, and then we hand it off to some APIs and then we get back some results. So if someone was to sit down and use this, like if I wanted to make my Where is Carmen Sandiego app, which I'm pretty sure I could do over a weekend, I would just take this and use this wholesale. Maybe I would apply some sanitization, but probably not. I'm moving fast and breaking things. So here we go. We decided, all right, we'll create a fairly straightforward feedback loop for fuzzing, where we have OpenCV on one end, we have a fuzzer on the other end. So the fuzzer we used was AFL. We compile OpenCV using its instrumentation. And we're looking for, so we define as input, here are images that we can feed to the system, and as output, you want a few different sort of more nuanced things than what fuzzers normally look for. So in addition to identifying, hey, is there a way that I can create a crash with an image, you also kind of care about in the scenario, can I create a hang with an input image? So can I get the system to stop processing an image and maybe take down the entire pipeline if the system is poorly constructed, which, hey, YOLO, probably is. Or can I create some kind of denial of service condition where it uses up all the memory? Or can I make it so that in order to recognize the features inside of the image, the algorithm needs to run for longer than the system will let it, thereby achieving sort of the same effect of concealing information through these modifications. So in this instance, normally hangs are not really that valuable when you're performing fuzzing campaigns, but in this instance, it sort of is. These hangs represent algorithmic complexity attacks, where you could, so algorithmic complexity attacks are the things that hackers start to look for when everything gets compiled with CFI and they don't want to admit to their friends that they do LFI and XSS. So we say, okay, we're going to find a way to shut the system down by providing it with denial of service input data, and then the entire system will go out to lunch, and the eyes turn off, and everything is good, and Carmen Sandiego roams the earth free. So in the course of our experimentation, we ran this fuzzing system for about 2 weeks of fuzzer time. Now, the other kind of frustrating thing is if you've done any fuzzing with AFL, this 10 million number should look laughably low. And that's because the computer vision algorithms take a long time to run. And it's frustrating because as far as I can tell, there's sort of no shortcut through this. Either, they're going to run for a long time and then finish or not finish. So, okay, the solution to this, like the solution to most problems in my life, both personal and professional, is heroic computing power. And we're poor, so we don't have that. Perhaps in the future we will. But from this, we identified about 3,000 crashes inside of OpenCV that were root cause down to about 4 or 5 different bugs that all had some different manifestations at different layers of the OpenCV stack, some in image processing, some in matrix multiplication, some in the actual algorithms themselves where the algorithms would fail to terminate. So the denial of service conditions so these were mostly images that would cause the program to infinite loop or run out of memory. These have been reported through the normative process in which these things are done via cert. So the truly troubling stuff is remote code execution. So there were like heap corruption and use after freeze inside of these, and we can show some of these images or sketches of these images in a minute because it's pretty freaky when you start to get the output of stuff that deceives computer vision systems. So this is dangerous because, sort of as I said before, these systems are doing reasoning. And they're doing it like all under the covers. So it comes back. So you say, here's 10 million images. I can't look through them all at once. You do it. You tell me what happened. When someone gets code execution inside of this, it's like they have, in a sort of squishy biological analog, they have code execution inside of your brain. So now after you look at some picture, there's this little demon running around inside of your head that's saying like, no, Carmen Sandiego just doesn't exist anymore. Like that concept is gone. It's void and it doesn't exist and it doesn't happen. So then the results that you get back from this decision-making process that's occurring in the computer vision system are just totally bogus because of these.
Yeah, so the real implication of this is that, an adversary no longer has to implant something. They no longer have to actively do anything. Simply by uploading pictures to Imgur, Flickr, Facebook, whatever, that people are downloading and getting popped. Like this, we uploaded all of the images that caused crashes. Not a single one of them were triggered in any AV software solution, and why should they, right? I mean, the pictures.
Gerbil would do better.
Yeah. So, this is an entirely new paradigm shift for attackers in their efforts to affect victims.
So another great thing the future has brought us is this fashion designer who independently from us had this same idea, and they looked at the world and they were like, well, there are these things out there that attempt to identify people shapes, and I'm going to make some statement by providing clothing that will mess up those things' ability to identify people. So this is interesting because sort of if you think philosophically about computer vision and people vision, camouflage historically has been about, we as people have developed over the course of the development of our, however you believe the development of our vision system and biological system and however all of that happened, it was developed to produce something that was good at identifying shapes. So, if the brain that you're carrying around between your ears is incapable of the brain you're carrying around between your ears is capable of telling the difference between a tiger and a tree because 2,000 years ago, proto-you did that and the other guy didn't. So we've had a long time to create these vision systems that we use to identify things, and camouflage is our attempt to mess it up. Computer vision is much less mature than people vision. So the ways in which it messes up are also way less mature than the way our vision messes up. So some of this is also related to this, this interesting paper that was published by a group at NYU titled A Curious Property of Neural Networks, where by hand they discovered that they can take a neural network-based classifier that looks at an image, sort of look at that classifier's inverse, figure out what pixels are relevant to the classification decision, and then change those pixels at a very low level such that the corrupted image looks indistinguishable to the original image, to the human eye, but to the computer's eye, it's the difference between classifying something as a cat and a bus. So we kind of do the same thing, but in an automated way, using fuzzing instead of by hand inspection of the images.
Yeah, and so the implication here is, if you're of the paranoid type and you don't want things like OpenCV recognizing your face, you're able to use fuzzers to add slight permutations to your profile pictures if you have them of your face, and you're now effectively drone-proof.
So this also, as I said before, this relates to this earlier idea of algorithmic complexity attacks. So we can automatically identify, or we try to automatically identify equivalents to those via fuzzing and automatic testing. So one way in which we can do that, or I thought about doing that, is by combining like fuzzing as dynamic analysis and invariant generation as a static analysis. So imagine if someone comes to you and they're like, hey, I've tried every input on this program and it didn't do anything bad. And you're like, oh, that probably means that program is good. So what does this mean? Well, right now what fuzzers do, or what the good fuzzers do, is they use a notion of code coverage when they decide which inputs are inputs they want to pursue and which inputs are one they want to discard. So the fuzzers want new code to be uncovered during the processing of new data, input data by the fuzzed application. So that's the metric that they use. So this needs to change some if you're looking for algorithmic complexity attacks. One way in which it should change is if you stick with the code coverage metric, you need to tell the system it's not enough to simply look at or process new code. You also need to have or prioritize the re-execution of code. So when you do that, like evolutionary fuzzing systems will automatically discover these locations in the program where there are algorithmic complexity problems. But there are other things you can do too. So with an invariant generator, you can say for particular locations inside of the program, what are the possible ranges that a variable can take on? And then you can start to compute an idea of, well, here's the path coverage that I have inside of the application, and then here's the value coverage that I have in this application. And when we take the product of those two, you wind up with an unenumerable thing, but it is a thing that starts to tell you, okay, if there are large values, and those large values are used as loop iterators, you probably want to try to get the loop iterator up to the maximum amount that it could be if it was going to trigger an algorithmic complexity attack. If there's something that's used as size in a memory allocator, then you probably want that value to be maximal, and your invariant generator can tell you what those maximal values are.
And also with this, there's a literal cost associated with this. As more and more people are moving to the cloud, they're doing fuzzing in a distributed manner. Able to induce algorithmic complexity attacks now imposes financial costs on your victim as well. Very high usage of CPUs, and if you're doing flooding of the sort, you now have you're hurting their pocketbook as well.
So what do we do about some of these things, and sort of whose responsibility is it to do something about these things? So in the case of like a library that processes images, someone comes to you and they says, hey, this library could do better. What change do you make? So many of the errors that we found, or not even really errors, but just misclassifications that we found using fuzzing in OpenCV, it's possible that the system would have done better if like a pre-processing pass runs that normalizes values of pixels in the image. So what do? Do you have a wrapper around this library that says, I'm going to invoke the classification library, I'm going to see if it errors, and then if it does, I'm going to run a normalization pass with one coefficient and then try again, and I'm going to try with increasing coefficients until eventually either I give up or the library succeeds in parsing it. But like, whose responsibility is that? And in some cases, you could say, oh, this is important. Like if you're going through a bunch of, like you can imagine in one context, it's very important for you to conclusively attempt to succeed or fail in every case. But in other contexts, it's okay if you drop like 0.5% of the data that you process on the floor. And the difference could be the like level of assurance that is expected in both of those contexts. So in some ways, these types of errors in data, like in big data processing, there isn't really like a one-size-fits-all solution the way there is in some aspects of application security, where you say, oh, the application should just always do X, and doing X is always safe and will never negatively impact anything. Huzzah, move on with your lives. But the other, in that doesn't always work when you're dealing with something as context-specific as big data processing.
Yeah, so as Andrew mentioned, there are defenses for this, and that defense is going back to the fundamentals. You're ingesting enormous amounts of public data. You don't know the people associated with, you don't know the sources associated with this data. Why would you trust it in your system? So in the instance of the Hadoop, if they had just treated it as a string of we're going to decode this once, and we're looking at for why would you allow that to be, why would you search elsewhere for this known string that should be here locally? And if that, if you treated it only as information, that exploit and data exfil would have never happened. Using these couple lines of Python code, we're able to take those 3,000 unique crashes that we were able to induce with OpenCV and take it down to 7 images. So there's a trade-off, right? So you're doing all of this, pre-processing on the images. You're ensuring the corpora, as we learned yesterday, the corpus of images that you're using is safe. But you're also doing this on millions of pictures or lots of lines of code. But you want your answer as soon as possible. So would you rather do it quickly or safely? And that's sort of the trade-off that people need to understand they're making when they make these decisions. So it's kind of time for, so here's some stats. And it's show and tell time. So we're going to talk about some of the, I'll just show you real quick. This is a subset of images that induce crashes within OpenCV. If they're ingested, you can download these and run them through OpenCV, and they're going to crash your computer in various interesting ways. So going through some of it, they vary in renderability and what's wrong with them. Each one of these induce a different crash. And as the previous slide mentioned, there's over 3,000 of them.
This is originally a picture of someone's barbecue, but...
Yeah, so going through, all of these render in Google Photos just fine. OS X rendered just fine. Nothing fails when you're looking at these. But of very hilarious note are the very normal-looking images that still induce crashes within OpenCV. The top one being a picture that says Justin Bieber was found alive in his apartment. Apparently, when you process that, OpenCV is equally despaired. There's a great quote by George Carlin here that shuts your computer down. And David Beckham, that's a handsome man that can break computer vision. So, yeah. With that really concludes our talk. And no one claimed the cherries, and I'm a little sad about that. But
Did we only get to 5?
Oh, I know personally. Or who was the first one to count to 5? 6. Who was the first person to count to 5? Or then come on, please come get the cherries. So yeah, we're available for questions if there are any.
Who would like it?
Both.
Yeah.
So all right, the question is, roughly, at what level in the OpenCV stack are the crashes present? Is it in image processing, or is it in the the computer vision algorithms? So the majority of them are in the image processing code. I didn't know this before I started looking at this code, but OpenCV has its own image processing library. What? All right. So I didn't know this before I started, but OpenCV has its own image processing library. It's not helping.
Shut your mouths, you're being rude.
Is this helping? Is this even on?
No, I don't know.
All right, whatever. So, awesome. The question was, at what level of the OpenCV stack were the crashes present in? So OpenCV has its own image processing library. I didn't know that. That's a little scary. So many of them are at that layer. Some of them are at the ones that are at a higher layer are usually a denial of service condition. So something where it'll run forever, or it'll produce like a nan, or it'll incorrectly produce nan, or it'll try to divide by 0 or divide by nan or something. So those are probably just gonna stop processing of an image. But that's the type of stuff that we found in that piece of software. I'm working on that. Like, so that's, yeah. So you want to take, you want to take the, so you always have the old image, and then you have the new image that produces the thing, and then you have a diff between them, and then you try to back out from that diff through the trace in the code, like where the change occurs. Yeah, I'm working on that, but I haven't finished that. So at some point, it would be nice if there was just like, oh, so if you should be able to just have a script that takes that applies this transformation, and then.
Yeah, so another thing of interesting note is that we're able to boil down the most severe bugs to just a couple bytes. And so it's not this couple megabyte image, it's just a couple bytes in a file, and you're able to push that through and achieve the same effect.
Now, those are the couple bytes are the ludicrous 2001 era bugs in the image processing code. The stuff that involves anything at the higher level, there has to actually be an image with a bunch of data for the algorithm to chew on.
Sure. And it's also of note, like, over the past probably quarter, Project Zero released some 0 days in the Samsung phones. Like, you just having an image on your phone could result in remote code execution. Over the holiday break, the libpng had some very severe holes in it that would also allow remote code execution. And this was all happening as we were concluding our research over the semester. So it was very interesting to see a lot of people finding these things simultaneously. I mean, so the question was, does it matter how the image gets fed? And the answer is no, as long as the checksum.
Well, I mean, so there are, so I've been told, oh, you shouldn't have been able to do that because that image processing service should do some degree of post-processing or like a transformation, and then it would reject the image. Like you see Google Photo will just like take the image and be like, yep, here you go. But so you could, so we had this 5 lines of Python that try to make sure that some images are within normal bounds before they get rendered, and if they tried to do that on their end, then they would reject stuff. But sometimes people don't seem to do that because they would have to incur this extra cost on their end. So you would ask them, oh yeah, if you receive 2 million images a day, like add an extra 2 million instructions onto each image that you want to bring in, and they would say, yeah, no, we don't have the compute for that, or we don't want to pay for the compute for that. So there is a trade-off in the checks that you could run on individual image imports.
Before we take the next question, we have one more jar of cherries. Please come get it. All right, please.
You're exempt.
So the question was, can we turn these, from digital to analog and, also induce a crash?
I'm not going to rule it out because there's past prior art of this being done with audio, but we haven't done that. But that would be another great thing to try. Yeah. So then, yes. Theoretically, anything is possible when you have the C code involved.
Yeah.
Yeah.
The
yeah.
real ugly T-shirt.
Yeah.
So are any of these artifacts removed when you upload to any image that's or something? Or are you basically saying if someone posts one of these images on Twitter, then they'll post every upload that's scraping social media and all that?
That's the point of our talk. That these are no longer safe places.
This is live. This is live on photos.google.com.
Yeah, so any one of these downloaded as is going to crash your system.
OpenCV.
Yeah, and some of them could be gifted. So, so of interesting note, Flickr does have pretty good pre and post processing, and they have the same conclusion as our Python script. So we uploaded all 3,000 images to Flickr, and it kicked out all the ones that Python script would have filtered out. Yes, these are the images. Yeah, so
Sorry, yeah.
Yeah.
I mean, yeah, we saw the like part of it, but what was the other reason behind that?
second.
What was this causing the crash? The images I mean, did you figure it out?
No.
That was related to his question earlier, where we need to backtrace like what these images are doing out. Yeah.
Yeah, this specific subset, what's going on here that's unique. Yeah. Sorry.
These in particular.
That is a good question.
Yeah,
I mean, we obviously didn't try that because we don't have an immediate answer, but that's a good experiment to run.
yeah, so
Sorry, the question was, is the crashing property of these images preserved if you convert them to JPEG and then back?
The ones that are not format.
Yes, yes, these images. And the answer is we don't know. But we could find out.
relatively quickly. So
If no one else has any questions, we're between you and dinner, so.
yeah.
Oh, yeah.
One more.
So you talked about anything related to the images is more in terms of data being up or whatever.
Yeah.
You talked about algorithms being targeted and taking track based on algorithmic vulnerability. You have you encountered.
Yeah, yeah. So some of the question is, are any of these examples of algorithmic complexity vulnerabilities? And these are, because these are not like at the format level. So when there's an algorithm that'll run to try to identify like a face, and it'll run on these, and while it tries to find a face in these images, it will produce a NaN, and then it just stops. So it says, oh, I've divided by 0, or I've produced some other non-representable value, and my processing of this image is over.
So yeah, personally, I'd like to thank everyone that came. This is, I came to ShmooCon, the original one, as a, plebeian, the underbelly of life, and it's an absolute honor to be on stage right here in front of you. So thanks everyone for coming.